So for this problem, we're going to assume that the number of turns is 200. We know that the self-inductance is given by the number of turns times the magnetic flux over the current. And for a toroid, the magnetic field is given by U naught Ni over 2 pi r. So L then would equal N VA over 2 pi r, which would equal U naught N squared A over 2 pi r if you do the algebra. And if we assume the numbers above, we have 4 pi times 10 to the minus 7 Weber per amp meter times 200 squared. The area is 5.0 times 10 to the negative 4 meters squared. We can assume those two if it's not given. I think I used those numbers for a reason. This might have been the previous example that I solved. And then the radius, let's assume the radius is 0.1 meter. So if we do all of this, we get about 4.0 times 10 to the negative 5th Henry, which is the same as 40 microhenries. And now we're told we want to find the induced EMF. The magnitude of the EMF is the self-inductance times the change of the current with respect to time. And so this is if we plug in these values that we know, then we know that we have L, which is 40 times 10 to the minus 6, or 4.0 times 10 to the negative 5 if you want henries. The change in amps is, it went from 0 to 6, so 6 minus 0 over 3 microseconds. Okay. And if we do this, we get about 80 volts.